In this video, we're going to look at another integration by parts example. So we're being asked to evaluate the integral of t squared sine of beta t dt. Again, u substitution technique isn't going to work for us here. There's nothing that's going to let u equal that's going to have our du be anything that's helpful to rewrite the integral. Again, since we've got a product of two functions, integration by parts should spring to mind to use as a technique of integration. So in this case, the function that'll get simpler when we differentiate is t squared. If we differentiate t squared enough times, it will go away. It'll become a constant. So we'll let u equal t squared. That leaves dv to be sine of beta t dt. Differentiate the u to get du is 2t dt. Anti-differentiate the dv. Well, an antiderivative for just sine would be negative cosine. We've got a beta times t that we'll have to adjust for, and that's where the negative 1 over beta comes in there in front. So now apply your integration by parts formula. We can replace the integral with u times v, so we'll get negative 1 over beta t squared cosine of bt, and then minus the integral of v du. Well, we've got a 2 and a minus 1 over beta for our constants. When I take the v and the du and multiply them together, pull those out in front of the integral, that minus sign will change to a plus. So that's where the plus sign comes from. You're getting a minus a negative 2 over beta that we've pulled out in front. And now we have the integral of t cosine beta dt. Now, can't write down this antiderivative the way it is right now. But we are a little bit better off than we started, right? We started off with t squared. We're now at t. If we do integration by parts one more time, the t will go away, and then we'll be able to do our antiderivative at the end. So let's let u equal t. Du then, of course, is dt. dv is everything else, cosine of beta t dt. And like before, we'll need to adjust with a 1 over beta because of that beta that's on the t on the inside of the cosine function. Antiderivative of cosine is sine. So now our integral is that minus 1 over beta t squared cosine of beta t from before. We still have the plus 2 over beta from before. We're replacing this integral now with uv minus v du using the integration by parts formula. So I need to make sure I have parentheses around that whole thing. That 2 over beta needs to be multiplied by the whole thing that we're replacing the integral with. U times v is 1 over beta t sine of beta t. And then minus v du. V du is 1 over beta sine beta t dt, and we can pop that 1 over beta out in front of the integral. Now we've got an integral, or an antiderivative, I should say, that we recognize. We've already done that once before, right? Up here we've done an antiderivative for sine of beta t. We're doing the same thing here. Notice when we do the antiderivative, a negative 1 over beta is going to come out in front. That's why this is now a positive 1 over beta squared cosine of beta t. All of this stuff is inside the parentheses here. This is what we replaced that integral with. Don't forget your plus c in the end. And now finally, if you want to clean some things up, you can distribute the 2 over beta through to both terms there to get a final answer here of negative 1 over beta t squared cosine beta t plus 2 over beta squared t sine beta t plus 2 over b cubed cosine of beta t plus c.